So today's lesson is going to expand on the normal distribution and finding, the probability that our data lies within uh, a certain range or a percentage um, using what are called z-scores. Now, the z-score is the measure of how far away or how many standard deviations your data point is from the mean. So the other day when we were working on problems like this, 404 and 632, 404 was um, one standard deviation lower than the mean for this problem, and 632 was one standard deviation above the mean. 746 was two standard deviations above the mean. So the z-score will allow us to find the probability of any data point. So, for example, what if in letter C right here, we wanted what percent of test takers scored between 400 and 600? Well, those are not clean values on our uh, curve or chart right here, so we would use z-scores to do that. A z-score of -1 would mean that your data is one standard deviation smaller than the mean, and a z-score of +1 would be one standard deviation above the mean. So using the z-score, well, we can get like a z-score of 1.5. Okay, that means our point is 1.5 standard deviations above the mean. So it's not exactly at one of these key values here. Okay? And we calculate the z-score by doing the data point minus x bar, which is the mean, divided by the standard deviation. That will give us the z-score. The z-score. And like I said, it tells you how many standard deviations the value lies above or below the mean. So what we're going to do for this is we're first going to find the z-scores of these values for this data point, this set of data. So it says, suppose the weight for men 18 to 24 years old is normally distributed with a mean of 170. So that's the x bar in this formula, and a standard deviation of 20 pounds. That is lowercase sigma. Find the value of the z-score for the given weight. And for us, we're going to round the z-scores to the 10th place or one decimal place. You will see some teachers will do 2 or 3 decimal places. We're just going to do 1. All right, so the z-score for 200 pounds is going to be the value 200 minus the mean divided by the standard deviation. Now, in your calculators, you might be tempted to type in something like this. You might go 200 minus 170 divided by 20. That's not going to give you the z-score. This calculator is doing 170 divided by 20 first, and then doing 200 minus that. So you're going to have to do either probably put in parentheses 200 minus 170, then divide by 20. This will give us the z-score of 1.5. So that value of 200 pounds is 1.55 standard deviations above the mean. 135. Okay, so let's do z equals 135 minus 170 over the standard deviation, again, is 20. All right, so we're going to type this into our calculator, parentheses 135 minus 170 divided by 20, and that gives us negative 1.75, but we're going to run to the 10th, so negative 1.8. So 135 pounds is 1.8 standard deviations smaller than the mean. Okay, so now for 170, well, 170 minus 170 over 20 Well, that's just going to give you 0. Okay? So that has a z-score of 0. And then the last one, 230 minus 170 over 20, that is going to equal 3. Okay, so what do we do with these z-scores? Well, with these z-scores, we're going to look it up on this table. And what this table tells you is the probability that your data is less than or equal to that value. So if we look at, and we're getting a little bit ahead of ourselves, but this 1.5, okay, we have on the vertical the whole number from -3 to +3, and then up on horizontally we have the 10th place. So if we're trying to find 1.5, we have 1 and then 0.5. Where do those intersect? Right here. So that means that 0.9332 of our data out of 1, or 93.32% of our data, is smaller than 200 pounds, because that was a z-score. So again, this table tells us to find the probability that our z value, or that our cut. So again, this table gives you the percentage less than or equal to your data point. So if you want something greater than, and we're going to get to that, you'd have to do 100% minus this. So let's go to the next page, and first we're going to change this to 230, which was what was on the other page. So this is the exact same data from the previous page. Let's just copy these z-scores. 1.5. This one was -1.8. This one was 3. And this one was 0. So we're going to find the probability that a data point is less than or equal to 200 pounds by, again, here's 1, and then here's 0.5. Where do they intersect? Right here at 0.9332, or 93.32%. Now letter B, the z-score is -1.8. So we go -1 and 0.8. Where do they intersect? Right here. So 0.0359, or 3.59%. Now a z-score of 0, well, we have 0, 0, so right here, which would be 50%. And then we have a z-score of 3.0, so 99.87%. So again, that tells us that 99.87% of our data is smaller than 230. And in this case, we're talking about weight of these men. So 99.83% of men 18 through 24 weigh less than or equal to 230 pounds, according to this data. All right, so in example 3 here, we have a mean of 17, so that's our x bar. We have a standard deviation of 3. Now, the very first one, I'm not asking for less than or equal to 15. This should just be x is greater than 15. So we're going to have to account for that, because when we use the table gives us less than or equal to, but we want greater than 15 this time. So let's find the z-score. Z is 15 minus 17 over 3. That is -0.66 repeated, so -0.7. So if we look up at our table here, negative 0.7 is 0.242 or 24.2%. But since I want greater than, it's going to be 100 minus 24.2. So now if I type that into my calculator, that gives me 75.8%. Right, then this one is less than or equal to 25, so their z-score is 25 minus 17 over 3. And if I type that into the calculator off screen, that will give me 2.666 repeated, or 2.7. So now I'm going to go up here and find 2.7, so 2.7, 99.65%. Oops. All right, so I want you to try the last two here. So pause the video, try those two, and then once you're done, unpause it to see if we get the same z-score and probability. All right, so this is what you should have gotten for your z-scores and your probability. Again, 0.3, people have trouble with that because they say, well, which zero do I take, the negative or positive one? Well, it was positive 0.3, so you would do positive 0 and then 0.3, and that's how you get 0.6179 or 61.79%. Okay? So again, just make sure you calculate the z-scores correctly and pay attention to your symbols to see if you're doing less than or equal to or greater than. All right? So thanks for watching. Make sure to like the video and subscribe.